Hello, and welcome back to another Craig and Dave Unscripted. We are on week 8 or level 8 of our Mission Encodeable journey. So we'll bring back our reoccurring stars, Harry and Anna. Hello to both of you, and thank you for joining us once again. So level 8, God, it feels like ages ago we started level 1, and things have really been ramping up. And I've got money on Harry saying it once this evening. I know I keep saying this, but these projects get better and better. And of course they do. I'm sorry, Harry. And of course they do, because as we introduce new skills and we build on them, you can do more things. So today, an essential part of learning to program, becoming fluent with files, and along with that, achieving exception handling excellence. So Harry, give us an overview, please.
Yeah, well, juxtaposingly, the projects in level 8 are really, really dreadful and absolutely don't recommend. They're not, I'm joking. Right. So the first part of level 8, it's kind of broken into 2 different sections, I'd say. So we start off with files and file handling. So, I mean, that's really useful. It allows you to store data. I think it's called persistently, isn't it? So after the program's finished running, you can still store data. So if you've got a game or something like that and you want to keep track of names and scores and things like that, it's obviously not really that great if it all goes once you've closed it. So we'll cover how you can save that in this level, and then you'll be able to use that going forward. So we cover reading and writing to files, and I think we use the TXT format in, I think, pretty much all of our stuff, although you can also use other formats as far as I'm aware. So if you wanted to use data from other sources, and we do have a little bit of this, in our level, then you'd be very open to doing that. So after that, we go on to more exception handling. So that's a different skill really to file handling, but it's basically a way that we can make programs more robust. So if, say, a user is asked to enter a number and they don't, if you want to convert it to an int, then usually you'd get a bit of an error if they'd entered something else. But with exception handling, you can just trigger your program to do something else and go, excuse me, that is not a number, try again, kind of thing. So that's really good. It just means that you'll get less of those error messages, because if your user's not behaving as you would like them to, then you can just tell them off instead of having it crash your program. So I think that's everything that's in level 8, and I will hand over to Anna now to show everybody a little bit more about the different projects that we have, which are actually quite good, and show you the steps in a bit more depth. So over to you, Anna.
All right, so first, probably becoming quite familiar now, we have the kind of introduction page to level 8. We have the capstone project, which we call Guess the Song. Essentially, you get a song with the artist, but with most of the letters taken out, and you can see here, we've given it a run. Appropriately, I know it is the song Computer Love by Kraftwerk. It's one that my dad has recommended. It's quite topical. But you can just enter that in. It should go correct. Hopefully I'll type it correctly. Oops. Hopefully I get correct. Yeah. And then we've got a few different songs in there, so it becomes a little game. It's quite nice using a file to do that. So again, tying together the skills you learn in the level. But then going more into depth of what we actually cover. First, we do an overview of files, which I think can be skipped out. So students might know that you can use files, but maybe not why. So I think it's quite nice that we've included a bit of what it is, why it might be good to use in the future. So I think that's quite a good introductory step. And then we take it bit by bit. We do it quite slowly. Each step kind of builds on the next. The previous. So we start off with opening and closing files, broken down into 2 sections, got some tables and things, because there can be quite a lot to digest, I think, with this. So we've tried to break it down as much as we can, a bit on closing files. And then we move on to reading files. And again, we just do lots of examples. We provide students with some content that they can put into their own files, and then they can test that themselves. And then we look at writing to files, and that's sort of all you need to cover at this point. So that's kind of almost the end. Then we do something slightly more advanced. But before that, we do the joke book, and it's based on the time to code approach, the time approach. So again, we provide the content for the file, and then students go through it, and hopefully they make a program that will do jokes. So it's quite fun. Obviously some cheesy jokes here, but yeah, and then students can, extend that with some better jokes, hopefully, than what we've come up with. And that's that project. They test it, all of that. Then we move on to iterating through lines in a file, which is quite a useful skill. Again, going through the syntax and an example. I know it's useful. I've been using it in my lessons at school. And then the final file handling project is movie statistics, which actually uses a lot of information that Harry and I have found. And then students can download that and use it in their program. And it's essentially a list of the most profitable movies ever. And you just display it in this table form. So it's quite interesting if you're into films and that kind of thing. You can just so much information. And then you can see all of this stuff. So it's quite good. And in this scenario, we allow students to download the file because it's a bit much to be copying. And this is a project where we just walk students through it. So hopefully they get a really good understanding of what they should be doing. So it's quite a nice project. I hope you agree, Harry. Yeah, we like it.
Just before we go on, Anna, because I know you're going to switch now to kind of exception handling. I have a lot of students, even A-level students, who seem to file handling. That's a complicated thing. It's not complicated. Look at how Hannah and Annie just presented it. You open a file, you read from it or write to it, you close it. That is pretty much all you need. This is all you need really at GCSE. Yes, there's a couple of ways reading to a file, which you went through. Am I appending or starting a new file? But that's it. Open a file, read or write, close a file. And you can be thrown into thinking, oh, this is an advanced skill because it's level 8. But we talked a lot in previous videos how we make functions a very early concept and they're not complicated. Unfortunately, we can't put everything in level 1. Something has to come later. So it might seem like an advanced concept because it's level 8. But, the way you've done it, you present it, there's the examples. Once you know the process, the code snippets are there. We've said it before. This is a great reference guide. You can use that again and again. And Harry correctly said at the very start, as soon as you do this, you have the ability to have persistent data beyond the life of your program. So, this is a really great skill. And then you'll use that again in A-level. Probably expand out from there. You'll learn to read and write from databases, and files. But, this is the fundamentals here. It's very simple and no more complicated, I think, than any other new skill you've been introduced to. I think you've said it lots of times, Harry and Anna. Don't move on until you've mastered it, until you can do that capstone project. And suddenly something which you think might be complicated, a lot of people see as complicated, you realise is just a tool in the toolbox.
Yeah, I'm guessing it may be because it's not always intuitive. The fact that you have to open a file and assign a variable to a file, which we might call a pipe or a pointer, and then you use that pointer to write data to the pointer effectively, which puts it on the file, and then you have to close the file. And I think sometimes the thing that catches people out is that you can only read or write. You can't read and write at the same time. So if you've got one file and you want to change some data in it, then you effectively have to open that file, read what's in the file, and make your changes in RAM, in memory, and then output the file again, either overwriting the original file that you've got or putting it into a second file. And I guess it's that bit that feels a little bit unintuitive, which is one of the reasons why it's slightly later, because once you can deal with records and things using for loops in RAM, then the next stage is to be able to use them from files as well. And of course, without going into a big teaching episode, which I promise I won't, it all harks back to days when data was stored either on paper tape or punched cards or magnetic cassettes. And so if you had tape drives, then you could only read them in one direction. And then, a new technology came along, the hard disk drive, that enabled you to have random access because the drive head could move to anywhere on the disk, and therefore it could read and it could write different parts of the disk seemingly simultaneously, which wasn't really the thing with tapes. So anyway, that's the reason why it's all very historical. And of course, today you've got different file formats like JSON and XML and other things that enable you to have more structured and human readable file formats. But because you don't really need to know much about those, certainly at GCSE you don't. It's why we don't include them in the scheme here.
Yeah. No, brilliant, Anna. So yes, take us on to, which is, as you say, very much the second part of level 8.
So the second part, it's quite a short part, is exception handling, which is how we touched on, kind of makes your programs more robust. So if you've written a lovely program, but the user maybe enters an integer where they should have entered a string, or you try and make a string into an integer and it just doesn't work, then your program doesn't crash and break and it's all okay. So it's a nice thing to learn how to do, because nobody likes their programs to break.
It also, Anna, of course, goes hand in hand with files, because
of course,
things can go very wrong the moment you introduce files. For example, your program's trying to read data from a file, and maybe the file doesn't exist because the user's deleted it, using the Windows operating system or whatever they happen to be using for their file management. Or a program tries to read more data from the file than exists in the file, or it tries to save a file and the disk is full. There might be any number of reasons why actually getting the data to and from that file isn't going to happen. And as you correctly say, if you try and do something that's not possible at runtime, you get the runtime error. And so your program will crash. There's no way of stopping it from doing that unless you build what are called these exception handling routines around the thing it's trying to attempt. So what you're basically saying is, look, this command would normally work. It's not like there's a syntax error or a logic error. This command would normally work. But sometimes there are exceptional cases where it could fall over. 99% of the time it won't, but you need to handle the 1% where it might. And that's where your exception handling becomes really, really useful. And why we tied it to files.
Yeah, I think it's a really nice example, actually, of how the files and exception handling link together. It's really nice showing how the scheme's being thought through. I think it's nice. In our lessons at school, we did files and exception handling, and it worked really nicely together. Anyway, so we go through exception handling. It can be a little bit not confusing once you know how you do it, but hopefully we introduce it in a way that's not too revolutionary or surprising or anything like that. So you can just straight away start putting it into your programs and handling the 1%, as Dave says, of times when it just doesn't work or something happens in runtime that shouldn't normally happen. And we go through some examples, as usual, the syntax, hopefully covering quite a broad range of things that you might want to go through. And then an example with file handling, as Dave was saying, there can be some issues that arise with that. So we've tried to make it relevant to what was learned earlier in the level as well, which is nice. And finally, we have the capstone project, which we looked at the start, which is the independent project that learners will complete at the end of the level. So testing their knowledge, making sure that you really understand what is going on and that you understand the skills that you need to have. and also maybe that makes you feel a bit good about yourself that you can make this project, because they do get better and better, and this one is a good one. And that's really all there is in level 8, so it's a nice level.
Oh, there is. There's plenty there. I thought
Well,
of something as
there's
well.
Yeah.
I thought of something which you haven't mentioned before. I mean, we say obviously we've got all the projects in here, and if you need more projects, you've got different projects over at Time to Code, so you've got even more. But of course, as you build through these levels, you're learning new stuff. There's nothing stopping you as a student as well going, oh, so that really cool capstoning project that I joined from level 7, I can make that more robust. I could maybe do something to my capstone project I did in level 8 or level 5, and I can't remember what that was now, but I could potentially do a high score table now, and I could save that to a file. There's nothing stopping you going back to previous capstone project, other stuff, and adding in the new skills. That's the beauty. It's obviously at the time we're making sure, and Harry and I are making sure that each project only uses the skills you've learned up to that point. So that's a great way of getting a bit of further practice. You can go back to something you previously quite liked and add the new skills you've learned. Yeah,
that's really important thought, actually, Craig, because a lot of teachers say to us, oh, I've exhausted all the resources. I've done all the projects. My students have done everything. And you're right. What we say is, well, you can't have ever finished a program because there's always something you could do to enhance it further, whether that's new functionality, whether it's the interface, whether it's the robustness, whether it's saving data to a file, whatever it is. I don't think any program could ever be complete in that sense. So it makes for great differentiation to be able to say to students, right, go back to your previous projects, make them better. And you don't even have to direct students in how to make them better. Just say, think about all the skills you've learned up until level 8, and now go back and apply those to the previous projects that you've written.
Yeah, and I should really say, I think as well at the start, but level 8, I think even though it's quite a high number in terms of, it's number 8, it's nearly at the end of the course. It's actually, they're not that hard, I don't think, either skill, but they are both techniques that I think can be useful, throughout all the programs in the whole course. So once you've done level 8, they're both really good things to go in and add. Like, I can't remember quite which level, I guess, actually, I think probably 6 or 7. I know we have deduction in there where the user has to enter numbers and things. And I think, it'd be quite easy for the user to break that by entering something that's not a number. So that would be a really good place, I think, to go back and apply it if you've learned exception handling to make sure they've entered that number or integer, I should say. So yeah, they're both really good techniques, and I think they can be applied super well, across the whole course. So hopefully everyone else will enjoy that, and they'll be able to use it in the projects in level 9, which I think probably ties us quite nicely to the end of the video.
It does. But before we go and introduce the next one, it's it's really important. You touched on something there, that there's a misconception that as you get through level 6, level 7, level 8, level 9, it just gets harder and harder and harder. That's not true. What it does is it introduces you to more commands, but those commands aren't any more difficult than the commands that have come before. They just allow you to do more with the language. And it's really, really important when you build a scheme of learning that even the later aspects of the scheme, they're still applicable and appropriate for all students in the class. Because let's face it, when you go to sit the exam, you may get a question that requires you to read or write data from a file. So all students need to learn that. They all need to be exposed to projects to practice those skills. And what you can't do with a scheme of learning is just make it harder and harder and harder and harder, because by the time you get to the end, you've only got a very small number of students that can actually do those skills at the very, very end. So you've got to make sure that all students, regardless of their understanding and ability, can all get to the end and can all be successful in every part of the scheme of learning. So, yeah, there's a lot of thought gone into that, actually, Harry, and you're right to highlight that.
Brilliant. Okay, well, for the last time, I'm going to pick on you this week, Anna. We're coming back with a level 9. What's the final level about in the next video?
The final level is all about two-dimensional arrays.
You are spot on. I felt like I've tormented the two of you these previous weeks by getting you
Yeah,
to
now
do
we've
that.
started like practicing. We're like, what's coming next? We're definitely going to be asked.
That's it.
But level 9 is an easy one to remember because it's last and there's one thing in it, so it's easy to remember. I'm lucky that you asked me.
Brilliant. Well, thank you again, you two, ever so much. Look forward to seeing you when we look at Mission Encodable's last level. Bye-bye for now.